Machines, not people, should be exploring the stars for now. A CNN News report.
In the last several weeks, two events demanded the attention of space enthusiasts. On March 30th, entrepreneur Elon Musk's SpaceX company successfully reused a previously flown rocket to launch a communication satellite into space. And on April 6th, American space pioneer John Glenn was laid to rest. In their own way, Musk and Glenn each represent the hopes and dreams of those who delight in the idea of mankind leaving the bounds of Earth and exploring the solar system and ultimately the stars. Over the past 50 years, we've seen men first orbit the globe and then walk on the moon. We were gripped by the fictional journeys of the Starship Enterprise, which explored the galaxy, encountering new life and new civilizations. Popcorn in hand, we watched Matt Damon struggle to survive in The Martian. We have dreamed of a time when humans can travel through space as readily as when early mariners unfurled their sails and headed west in search of new lands. But we might not have stopped and asked an important question. Should we be doing that? Now, I'm not asking whether we should explore the universe. I also dream of the day that we become galactic citizens. The question is whether the initial exploration of space should be done by humans or by robots. I would argue that, for the moment, robotic exploration should have the upper hand. Proponents of the astronaut-preferred camp point, quite rightfully, at the versatility and independence of humans. Fans of human spaceflight are certainly correct when they remind us that humans are highly versatile. People observe the conditions around them and can react to circumstances as needed. However, people are also fragile. They need food, water, and air. They can exist in only a narrow range of temperatures and find inhospitable both vacuums and a radioactive environment. While some adventurers might prefer to remain in space forever, many of them expect to land gently back on Earth. All of these considerations are extremely challenging and not important for robotic missions. Engineering spacecraft that satisfies human requirements is also very expensive. The International Space Station cost about $170 billion, all costs given in 2017 dollars, resulting in only a large facility locked in a low Earth orbit. The storied Apollo missions included a mere 6 lunar landings at an inflation-adjusted cost of $120 billion. Possible manned missions to Mars are imagined to cost about $1 trillion, with the outcome being limited exploration of the red planet by about 2030, with some estimates saying 2050. And a mission with that price tag would hamstring the rest of the space program. In contrast, robotic exploration of the solar system is far less costly. The Cassini mission to Saturn cost about $3.2 billion. The Mars Curiosity rover cost about $2.5 billion. These and other missions have been wildly successful in teaching us about places where literally no one has gone before. Mars missions have explored ancient streams where knee-deep water once flowed and have found organic carbon embedded in surface rocks. In addition, there are methods for exploring the cosmos that don't require actually going to the place under study. The Hubble telescope has perhaps revealed more about the universe than any other scientific instrument. Cost about $14 billion, including imaging the first galaxies formed, and played a key role in the discovery that the expansion of the universe is accelerating. And the wildly successful planet-hunting Kepler satellite weighs in at under $1 billion. Manned programs can cost tens or hundreds of times more than the robotic missions. But it's not just about the money. There are 3 important goals we need to achieve from our space program. The first is monitoring our own world, resulting in storm warnings and help in understanding our complex planet, which can best be done by tireless satellites orbiting the Earth. The second is to learn more about our solar system and the more distant universe. On this, the case is also clear. Robotic exploration, through either space probes or telescopes, provides a much better yield for much lower money. The final goal is that of making humanity a multiplanetary species. By definition, this includes manned spaceflight, but the question is really how we should achieve that objective. Developing human spacefaring technology is crucial, but first we need to decide where to go. The moon is a dead planet, and Mars is not nearly as welcoming as a new world was to the Spanish explorers. In fact, there is no place in our solar system where pioneers can simply drop seeds in the soil and wait for food to pop out of the ground. For that, we need to look at distant stars. And interstellar exploration is also something in which robots will lead the way. Following the identification of a possibly habitable planet by the Kepler satellite, or perhaps Plato, a European Space Agency planet hunting telescope scheduled to be launched in 2024, the next step would be a survey of the planetary system by an unmanned probe. This might be patterned after billionaire investor Yuri Milner's breakthrough Starshot, or some other approach. Here, expected advances in artificial intelligence will become crucial. A round-trip radio signal to Proxima Centauri, our nearest stellar neighbor, will take 8 years. And if we chose to explore the nearest Sun-like star, the signal transit time is more than 24 years. With a multi-year time lag between messages, the interstellar probe will have to be able to execute independent judgment. Only once a habitable planet is identified by these robotic approaches will it be time for a manned mission. With a welcoming destination beckoning to them, a team of intrepid men and women will leave the solar system and strike out for a new home. And, at that moment, Homo Interstellaris will come of age.